In this video, we'll be covering the basics of friction. To stop a moving object, a force must act in the opposite direction of the direction of motion. Here is a demonstration of friction where someone pushes a book across a table. In this demonstration, the pushing force makes the book slide across the table until it is at rest again. So what exactly is happening? At first, the book is at rest before a pushing force moves the book across the table. A frictional force that acts in the opposite direction to the direction of motion slows down the book until the book is at rest again at the other side of the table. Just as a side note, this is an example of sliding friction because the book slides across the table, but we'll get into that a little later. So finally, how can we define friction? Friction is a force that opposes the motion of an object. There are 4 different types of friction. The 4 main types of friction are static friction, sliding friction, rolling friction, and fluid friction. The first 3, static, sliding, and rolling, occur between solid surfaces. Fluid friction occurs in liquids and gases. In this next part of the video, we'll have some more demonstrations starring my good friend Amber Morrison. The first type of friction we'll be looking at is static friction. Static friction acts on objects when they are resting on a surface. An example of this is walking. Walking is an example of static friction because there is no relative motion between the shoe and the ground. Without static friction, Amber would be slipping and sliding, making it more difficult to walk. Now we're going to take a look at sliding friction. Sliding friction acts on objects when they are sliding across a surface, like the book we saw earlier in the video. Sliding friction is weaker than static friction. This explains why it's easier to move furniture once you get it moving. An example of sliding friction is writing with a pencil. Here, Amber is moving this orange ottoman to demonstrate sliding friction, and another demonstration where Amber is sliding her feet across the floor. Rolling friction acts on objects when they are rolling across a surface. Rolling friction is much weaker than both sliding friction and static friction. This is why ground transportation uses wheels. We have 2 more demonstrations here to show rolling friction. Here, Amber pushes a cart on wheels. In this next demonstration, Amber pushes herself in a wheeled chair. Fluid friction acts on objects that are moving through a fluid. An example of fluid friction is pushing your hand through a tub of water. Air resistance is another example of fluid friction. Just a reminder, remember that fluid friction occurs in liquids and gases. Static, sliding, and rolling friction occurs between solid surfaces. So how can we calculate the force of friction? We can use the formula F equals mu times N, where mu is the friction coefficient and N is the normal force. The normal force is equal to the weight of an object, which can be calculated using mass times the acceleration due to gravity. With that being said, the force due to friction formula can be rewritten as F equals mu times M times G. M equals the mass, and G equals the acceleration due to gravity. The first step to find the force of friction is to find the normal force. The normal force always opposes the force due to gravity and is perpendicular to the surface. Then you have to use the right friction coefficient, which depends on the object and the situation. By situation, I mean whether the object is experiencing kinetic or static friction. Simply put, kinetic friction acts on moving objects, and static friction acts on objects that are not moving. The materials of the surfaces and the object also affect the coefficient of friction. The coefficient of kinetic friction is generally smaller than the coefficient of static friction. Here is an example problem where we have to calculate mu, the coefficient of friction. A block weighing 200 newtons is pushed along a surface. If it takes 80 newtons to get the block moving, and 40 newtons to keep the block moving at a constant velocity, what are the coefficients of friction? For the coefficient of static friction, we need the force needed to get the block moving, which is 80 newtons. We can then plug that into the F equals mu times N formula, where N, or F sub N, is the normal force. This is equal to the weight of the block, 200 newtons. After dividing both sides by 200 newtons, we can calculate that the coefficient of static friction is 0.4. There are no units. For the coefficient of kinetic friction, we need the force needed to keep the block moving at a constant velocity. This is given in the problem, 40 newtons. We plug 40 newtons in for F, or F sub F, the force of friction, and the normal force is still equal to the weight of the block, 200 newtons. After dividing both sides by 200 newtons, we calculate that the coefficient of kinetic friction is 0.2. This video is just a basic introduction regarding the force of friction. Thanks for watching!